So this is what you might call a classic windmill. It's got a circular disc with the blades attached, and when the wind comes along, the wind interacts with the blades and turns the windmill round. Now the power that you get available from the windmill is dependent on, obviously, on the wind speed, but it's actually dependent on the wind speed cubed. So if you double the wind speed, the power goes up 2 times 2 times 2, you get 8 times the power. And if the wind drops by a half, then you get an eighth of the power. So as the wind naturally is going up and down in most places, the power available from a windmill is also go up and down. And that's the problem with wind power. So it's very good when you're in a place where there's continuous wind, like an island in Scotland, for example. But when you're in a garden in Sussex, like it is today, the wind's going up and down, the windmill's going fast and slow. So the blades are mounted on a circle here, and as the wind comes along, it interacts with the blades and turns the windmill. And that's connected along a horizontal axle here to this pulley. So as the wind comes along, it turns the axle, turns the pulley, and that's connected to a generator down below, and which spins the magnets and makes electricity. You can see it goes beautifully. Trouble with this sort of windmill is that the blades need to point into the direction of the wind. So you always have to steer this windmill into the wind. So that's the problem with the horizontal axis windmill. You have to move the windmill to follow the wind. This is an example of a vertical axis windmill, obviously because the windmill rotates around a vertical axis. And the nice thing about these windmills is that it doesn't matter which direction the wind comes from, it will always turn. So you don't have to point this windmill into the wind to get it to turn. On this particular example, you can see that the axle goes down to the bottom where it's joined onto a pulley here, and that drives the generator. And you can see as I turn it that it's producing electricity. It's a really nice way of generating electricity without having to steer the windmill into the wind. This is an unusual design of a windmill. It's called the flutter gen. It was designed by Peter Allen Sharp, a Californian inventor. And he wrote to me and I built this prototype. Basically what you got string attached to a lever here. And when the wind blows, the sails that are attached to the string flutter. And they go down to here, and the movement of the string moves the generator and generates electricity. So we call it the flutter gen. And it's very, very simple.